So this is a tutorial about the software of the laser writer, which is called LPKF Protolaser LDI. You can find it either on the desktop here or in the taskbar at the bottom. So when you open it, you will see a screen like this. It will have a log of all the things that have happened with the instrument itself, and you can see that we have earlier on for the fabrication, we have ejected the sample tray, the injection was completed, and then we loaded our own sample, and the load was completed as well. So if you want to import a drawing that you made with your own CAD software in this system, you would go on this PL button, hit import, and you have to look for a DXF file. So when you are drawing your structures in your own software, remember to export it in this .dxf format, which is a very common format for CAD drawing software. So I'm going to select this training design 2. So I'm going to hit open on that, and you're going to see the structure here. So the first thing that you usually have to do when you have a structure like this that you've just imported is to actually scale it. So if I zoom out on here, you will see that this yellow square, this is the working area of the system, and you can see that it's a lot bigger than the structure that I have. And this structure was designed to fit within a single microscope slide. And the point here is that the software doesn't do any unit conversion. So essentially, one unit in your own CAD software will be converted into one unit in this software. And this software uses micrometers as the base unit. So when I prepared my drawing, I prepared it in millimeters. So if a line was, say, 30 millimeters long, I would have input 30 to mark the length of it. So if I were to draw this same line in this software, I'll have to input 30,000. So the first thing I need to do is to scale the drawing. So I'm going to select the scale tool, and I'm going to select the whole structure, right click, and I can select the base point somewhere here, and I can input the value 1000. And you're going to see that in the command bar down here. You don't want to be scaling it by hand, even though you can, but you want to input an exact number, which is the one that you know is correct. So I'm going to hit enter on that, and now I can zoom out, and I can see that the structure that I have is of a reasonable size compared to the yellow square. So the yellow square is 100 by 100 millimeters, so that kind of gives you the scale of this drawing. So moving on to what do we do next. So the way that the software works is that you have to provide it some enclosed shape. So any enclosed shape, which is delimited by a single line, can be converted into an area that the laser writer will expose. So for example, these circles that I've put in here, which are some practice inlets for punching in the PDMS, I can select this, and you can see that this is one single enclosed shape. So any enclosed shape really will work, but you have to be careful that it is enclosed. So for example, if I draw using the line tool, for example, I draw just a random shape that looks like this. This is not an acceptable shape, so the software will not know what to do with a shape like this. On the other hand, we'll just turn on the snapping and the polar settings. If I close this shape, this will now be an enclosed shape, and I can use this whole selection as an area that will be exposed by the laser writer. So you see, we can use actually this rectangle here as an example. So if you want to assign a certain exposure to this rectangle and you want to expose this area, then what you want to do is select the whole thing. And now you can actually see that this shape that I've drawn, it's actually a collection of 4 lines. This is not a single line, but it's a collection of 4 lines that just happen to start and end in the right places. So you see that as much as I zoom in, these lines will terminate exactly in the same point. So this is what you want, but for you to make sure of this, you can actually select an enclosed shape and hit the join button, and this will make sure that all the lines that you have selected inside your shape actually belong to a single shape. So you see that now, instead of this being a a shape that happens to be just a collection of 4 individual lines, if I click and select a single line, it will actually select the whole shape. So once you have created an enclosed shape that you want to expose, you can then tell the laser writer software that this is a shape that needs exposing in the process. So you can hit this, you can go in this block section of commands, and you can hit create block, and now you will come up with this window here, which is asking you to input a name for the block. So I'm going to call it just, for example, shape underscore 01. I'm going to keep this option ticked, convert to block, and I'm going to ignore everything else. Okay, so if I now hit OK, you will see that the block, so the shape that I have drawn before, has been converted into a block, and it's now got this solid white filling color. So when you have a solid white shape within your drawing area, it means that this is a shape that the laser writer recognizes as an area that needs to be exposed. And now the next thing to do is to set the attributes for this shape. So I'm going to select this now, and by default the attributes have some default initialization values. So you have to set these yourself according to the exposure settings that you want to use. So I'm going to click the attributes button over here. This is going to come up with this additional menu. So you can assign a profile, and you can see that several users have saved their own profile over here. I would normally just stick to the default fine tool and the default coarse tool. The difference between the two being that the fine tool has a laser spot diameter of approximately 1 micrometer, whereas the coarse tool has a laser spot diameter of 3 micrometers. So because this structure is quite big and all the structures within this sample are quite big, I'm going to stick to the coarse tool. Okay, so I'm going to select the default coarse tool, and you will see that this will initialize some of the values that are in the attributes sections. So the two values that you really care about are the tool type, which is set to coarse, and you can edit that here. And you should only input the two keywords, either coarse or fine. And I'm going to leave this at coarse because this is the tool that I want to use. And the second key parameter that you want to set is the tool exposition, which is the exposure dose of the structure that you're using. So this is set by default to 5,000, and this should be in units of millijoules per centimeter square. So I know that for the photoresist that I'm using and for the film thickness that I'm using, the correct value for this to get a good exposure of the structures is 800. So I'm going to hit 800 and press enter. So I can go back now onto the attributes, and I should see that the tool exposition is set to 800. In addition, you have this tool spot spacing setting, which I normally leave at 0, which will give you the maximum resolution and maximum quality of the exposure. And this essentially is an additional offset that you can specify, because the exposure actually happens as a collection of dots. And this spot spacing setting allows you to set an additional offset between the different dots in which the laser writer uses to do the exposure. Then you have this setting about the Z offset. This is useful if you're having very, very thick films, say 50 micrometers or even more. And you can adjust the laser focal plane compared to the leveling procedure that we will do afterwards. For thin films up to, say, 50 micrometers, I would usually leave this at 0. But you can tweak it if you want the laser to focus on the top of the film, around the middle of the film, or on the level of the substrate. So this is a parameter you can play with in that regard. And then you've got these three settings, which I'm not very familiar with, which I use to adjust the grid locations and to possibly correct for some stitching errors when the software, when the laser writer exposes different grids within your drawing. So for this, you can refer to the manual of the machine. So I'm going to stay with tool type coarse, tool exposure 800, and I can press OK. And this now is a shape that the laser writer will recognize as a region that needs to be exposed with the settings that I assign. Now, actually, this is not a shape that is useful for me, so I'm probably just going to delete it now. And I can show you how I would go about setting up my own structures. So I'm just going to select this and press the delete key and move on with my own structures. So for my own structures, you see that I've got these two long winding channels with these inlets here. So all I need to do now is to actually select all of these and make sure that they're all joined together. So I'm going to select all these shapes and lines, like so. Select them all like that. And now I'm going to hit the join command, and this should now belong to a single shape. Okay, so that's what I wanted, and I'm going to do the same thing with the one below, which is just a slightly different size of the channels. And that's it. And so now I can hit the join button, and that's going to be part of the one shape. So you see now that I've got the lettering here. I would like to select all the letters and hit the join button, but unfortunately that will not work. You can only join one shape at once. So if I select this, I can hit the join button, and this will now be a single enclosed shape. But if I were to do the same thing on these two shapes, you can see that these are separate shapes. So if I select them both and I hit the join button, only one of the two will be joined, whereas the other one will still be separate. So I have to join each of these individually, and I have to do this for all the shapes that I've put in my drawing. Okay, so I'm going to go ahead and do that. It's a slightly tedious process the first time you do it, but hopefully you only have to do it once. Okay, join. And this is the last one, and I'm going to do the same thing on the one on top. It's always a good idea to select it and check that you've joined it correctly. Now, just for in the interest of time, I'm just going to trust that I'm doing it correctly. Join all of these. Hit the join button. There we go. There. So now all these shapes are joined, and they are ready to set the attributes. So I'm going to create separate blocks for these four inlets and for the channels. But in principle, if I was using the same settings to expose the whole sample, which is very often the case, you could select all the structures on your drawing and assign a single block to all of these together. So I'm now going to select all of these and hit the create block button. And now I'm going to call this channels. Convert to block. I'm going to hit OK, and now you see that they've turned solid white in color. And now I'm going to select this block and set the attributes to the default coarse tool and 800 on that. So I'm going to hit OK, and now separately I'm going to create a new block for the inlets themselves, and I'm going to call it inlets. I'm going to hit OK. And that's it. So I'm going to also set the attributes for that. Default coarse tool, tool exposure, 800. And I'm going to hit OK. Now you have to remember that a single block can only have one set of attributes. So if you want to expose different parts of the drawing in different ways, with different settings, then you need to create separate blocks for each of these individually. Also, once you create a block, this block becomes permanent and you can't modify the shape anymore. If you wanted to do that, you would have to go revert the block creation. So you would have to select the block that you want to edit. You hit the explode button, and this will essentially break apart the filling, which is the block, from the shape itself. So now I can select the block. You see, I'm selecting all of these shapes, but you can see that there's also this white edge, which is actually the shape that has been used to create the block, and if I hit the delete button now, I have removed the filling and I'm left with the shape. So this is now back to the shape that I had in the beginning, and I can use this now and modify it and edit any position of any lines, and then when I'm ready I can recreate a block as I did it before. So I'm going to have to redo it now. So I select these together, hit create, inlets. Okay, it's going to ask me if I want to redefine the block, and if I want to overwrite, I'm going to hit yes, because I want to do that. And now I'm going to select it again and reset the attributes to coarse, tool, and 800 exposure. I'm going to hit OK, and that's it. Okay, so now the structures are pretty much ready to be exposed. The final thing I have to be careful about is that I position the structures within the area of my sample. So the software will not tell you if you don't do this correctly, but it has a way to help you to see where you're supposed to put the structures in the first place. So if I go on this Protolaser LDI tools, and I go on the substrate section, and I select the rectangle 75 by 25, this is the normal glass slide, and you'll see that that is positioned vertically. So what I need to do next is to go in my drawing manipulation, select the whole structure, right click, and then rotate it by 90 degrees. I can again do this just graphically, and here is my structure. Now I want to move it, so I select it all, and I move it roughly in the center of the glass slide. Okay, it's not really in the center, so I'm going to reposition it slightly, roughly there. So you want to make sure that all the blocks that you have defined are within the area of the sample that you're going to expose, which will usually be indicated by a yellow shade, like a yellow rectangle in this case. If you had different substrate, you could of course select all the different shapes for this. Okay, so now the structure is ready to expose. If you want to check the location of the grid, so you know that the exposure in the system happens along a grid pattern, so you can use the show coarse grid to check what is the location of the grid, and you can readjust the position of your structures according to this. So you can use the coarse grid, or you can use the fine grid, or you can show both. So I'm not interested in that right now, so I'm just going to skip that part. So once you have a drawing like this, you are ready to carry on with the exposure.